The secondary conductors from the transformer to the pump controller are classified as power wiring, not control wiring. Therefore, these conductors must adhere to the regulations outlined in Article 215 of the National Electrical Code, or NEC. One crucial requirement is the separation of these conductors. This separation can be achieved in one of two ways. Firstly, by running each conductor in a separate conduit, or secondly, by housing them in separate compartments within a multi-conductor cable. The installation of these conductors must conform to specific methods detailed in the NEC. These acceptable methods include 1. Utilizing type NM or SE cable, adhering to the guidelines specified in section 334.15. 2. Employing type UF cable, as permitted under section 334.10. 3. Installing the conductors within a conduit system using rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. 4. Using a cable tray system designed for electrical cables. 5. Implementing a busway system. Regardless of the chosen method, the conductors must be appropriately sized to handle the electrical load of the fire pump. Additionally, they must be protected against overcurrent conditions as dictated by section 240.4. It's imperative that overcurrent protection is provided back to and including the disconnecting means. The conduits or raceways housing these conductors must be securely fastened following the instructions outlined in section 300.11. The support and spacing of these conduits or raceways must also comply with the requirements detailed in section 300.14. Where these raceways or cables penetrate walls or floors, fire-stopping measures are mandatory. Refer to section 300.21 for guidance on proper fire-stopping techniques. The entire installation must be executed in a neat and workmanlike manner, ensuring that the conductors are adequately protected from physical damage. Let's delve deeper into each of these aspects, starting with the conductor separation requirement. The intent of separating the conductors is to minimize the risk of a fault condition affecting multiple conductors simultaneously. If a fault occurs in one conductor, the separate conduit or compartment acts as a barrier, preventing the fault from spreading to adjacent conductors. This enhances the overall reliability and safety of the fire pump system. Now, let's examine the permissible wiring methods in more detail. Type NM cable, commonly known as non-metallic sheath cable, is typically used in dry locations within buildings. Section 334.15 outlines the specific requirements for installing NM cable, including support intervals, protection against physical damage, and allowable uses. Type SE cable or service entrance cable is designed for use in service entrances and feeders. It can be used in both wet and dry locations. Section 334.10 specifies the permitted applications and installation requirements for SE cable. Type UF cable or underground feeder and branch circuit cable is suitable for direct burial in the earth and for use in wet locations. It's often used for supplying power to outdoor equipment or for underground runs. Section 334.10 details the allowable uses and installation guidelines for UF cable. When using conduit, rigid metal conduit, intermediate metal conduit, and electrical metallic tubing are all acceptable options. Rigid metal conduit provides the highest level of physical protection and is suitable for both indoor and outdoor applications. Intermediate metal conduit offers a balance of strength and cost-effectiveness and is also suitable for a variety of applications. Electrical metallic tubing is a lightweight conduit option that is typically used in dry locations. The choice of conduit type depends on the specific environmental conditions and the level of physical protection required. Cable trays provide a flexible and organized way to support and route cables. They are often used in industrial and commercial settings where there are numerous cables to manage. Busways are prefabricated electrical distribution systems that consist of busbars enclosed in a protective housing. They are typically used to distribute power to large electrical loads. The selection of the appropriate wiring method should take into account factors such as the environment, the level of physical protection required, and the cost. Next, let's discuss conductor sizing. The conductors must be adequately sized to carry the full load current of the fire pump motor. plus any additional loads that may be connected to the circuit. The NEC provides tables that specify the ampacity or current carrying capacity of different conductor sizes based on their insulation type and installation conditions. It's crucial to select conductors that have an ampacity sufficient to handle the expected load current without overheating. Overcurrent protection is essential to protect the conductors and equipment from damage due to excessive current flow. Overcurrent protection devices such as fuses and circuit breakers are designed to interrupt the circuit when the current exceeds a predetermined level. Section 240.4 of the NEC provides detailed requirements for overcurrent protection, including the selection of appropriate fuse or circuit breaker sizes. As previously mentioned, overcurrent protection is required back to and including the disconnecting means. This means that there must be overcurrent protection at the transformer secondary and at the disconnecting means that serves the fire pump controller. The disconnecting means is a switch or circuit breaker that allows the power to the fire pump controller to be shut off for maintenance or in an emergency. The conduits or raceways that house the conductors must be securely fastened to prevent them from becoming loose or damaged. Section 300.11 of the NEC provides specific requirements for securing conduits and raceways, including the use of appropriate supports and fasteners. The support and spacing of conduits and raceways are also important to ensure that they are adequately supported and that they do not sag or become damaged. Section 300.14 of the NEC provides guidelines for supporting and spacing conduits and raceways. Fire stopping is required where raceways or cables pass through walls or floors to prevent the spread of fire. Fire stopping materials are designed to seal the openings around the raceways or cables and to prevent flames and smoke from passing through the openings. Section 300.21 of the NEC provides requirements for fire stopping. The entire installation must be performed in a neat and workmanlike manner, adhering to industry best practices. This includes ensuring that all connections are properly made, that the conductors are neatly routed, and that the equipment is securely mounted. The conductors must also be protected from physical damage. This can be achieved by using appropriate conduit or raceways, by routing the conductors in protected areas, and by using guards or barriers to prevent accidental contact. In summary, wiring a 480 volts to 208 volts fire pump requires careful attention to detail and strict adherence to the requirements of the National Electrical Code. By following these guidelines, you can ensure that the fire pump system is safe, reliable, and code compliant. Remember to consult the latest edition of the NEC and to seek guidance from a qualified electrical professional if you have any questions or concerns. The requirements outlined in Article 215 of the NEC are designed to ensure the safe and reliable operation of feeders, which are the conductors that carry power from the service equipment to a subpanel or other distribution point. In the context of a fire pump installation, the secondary conductors from the transformer to the pump controller are considered feeders. Therefore, they must comply with all applicable requirements of Article 215. The separation of conductors, as previously discussed, is one such requirement. Another important requirement is the proper sizing of the conductors to handle the load current of the fire pump motor. Article 215 provides guidance on calculating the minimum conductor size based on the motor's horsepower rating and voltage. It's crucial to ensure that the conductors are adequately sized to prevent overheating and voltage drop. Overcurrent protection is another critical aspect of feeder wiring. Article 215 requires that feeders be protected by overcurrent devices such as fuses or circuit breakers that are sized appropriately for the conductor ampacity. The overcurrent devices must be located at the point where the feeder originates and at any point where the feeder size changes. Grounding is also an essential element of feeder wiring. Article 215 requires that feeders be properly grounded to provide a path for fault current to return to the source. This helps to protect against electrical shock and to prevent damage to equipment. The grounding conductor must be sized according to the requirements of the NEC and must be connected to the grounding electrode system. In addition to these general requirements, Article 215 also addresses specific situations, such as feeders that supply multiple loads or feeders that are installed in hazardous locations. It's important to consult the NEC for detailed guidance on these specific situations. The use of appropriate wiring methods is crucial for ensuring the safety and reliability of the fire pump installation. The NEC provides a variety of wiring methods that are suitable for different applications and environments. The choice of wiring method should take into account factors such as the environment, the level of physical protection required, and the cost. As previously mentioned, acceptable wiring methods for fire pump feeders include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, cable trays, and busways. Each of these wiring methods has its own advantages and disadvantages. Rigid metal conduit provides the highest level of physical protection and is suitable for both indoor and outdoor applications. However, it is also the most expensive option. Intermediate metal conduit offers a balance of strength and cost-effectiveness and is suitable for a variety of applications. Electrical metallic tubing is a lightweight conduit option that is typically used in dry locations. Cable trays provide a flexible and organized way to support and route cables. They are often used in industrial and commercial settings where there are numerous cables to manage. Busways are prefabricated electrical distribution systems that consist of busbars enclosed in a protective housing. They are typically used to distribute power to large electrical loads. The installation of these wiring methods must comply with the requirements of the NEC. This includes ensuring that the conduits and cables are properly supported and secured, that the connections are made correctly, and that the wiring is protected from physical damage. Fire stopping is an important safety measure that helps to prevent the spread of fire through walls and floors. When raceways or cables penetrate fire-rated walls or floors, the openings around the raceways or cables must be sealed with a fire-stopping material. Fire-stopping materials are designed to prevent flames and smoke from passing through the openings, thereby slowing the spread of fire. The NEC requires that fire-stopping materials be listed and labeled for the specific application. This means that the materials must have been tested and certified by a recognized testing laboratory. The installation of fire-stopping materials must also comply with the manufacturer's instructions. This includes ensuring that the openings are properly cleaned and prepared, that the fire-stopping material is applied in the correct thickness, and that the material is properly cured. It's important to note that fire-stopping is not the same as insulation. Insulation is designed to reduce heat transfer, while fire-stopping is designed to prevent the spread of fire. In some cases, a single material may provide both insulation and fire-stopping properties. However, it's important to ensure that the material is listed and labeled for both applications. The requirements for fire stopping are outlined in section 300.21 of the NEC. This section provides detailed guidance on the selection, installation, and maintenance of fire stopping materials. It's crucial to comply with these requirements to ensure the safety of the building and its occupants. In addition to the specific requirements outlined in the NEC, it's also important to follow industry best practices for electrical installations. This includes ensuring that all work is performed by qualified and experienced electricians, that all materials and equipment are of high quality, and that the installation is thoroughly inspected and tested. A well-designed and properly installed fire pump electrical system is essential for protecting life and property. By following the requirements of the NEC and adhering to industry best practices, you can ensure that the fire pump system is safe, reliable, and code compliant. Remember to consult the latest edition of the NEC and to seek guidance from a qualified electrical professional if you have any questions or concerns. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to ensure that your fire pump electrical system complies with all applicable codes and regulations. The NEC is a comprehensive document that covers a wide range of electrical topics. It's important to have a thorough understanding of the NEC to ensure that your electrical installations are safe and code compliant. The NEC is updated every 3 years, so it's important to stay current with the latest edition. You can purchase a copy of the NEC from the National Fire Protection Association or NFPA. You can also find information about the NEC on the NFPA website. In addition to the NEC, there may be other local codes and regulations that apply to your electrical installations. It's important to check with your local building department to determine which codes and regulations are in effect in your area. Working with electricity can be dangerous, so it's important to take precautions to protect yourself from electrical shock. Always to energize the circuit before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work for you. A properly installed and maintained electrical system is essential for the safety and functionality of any building. By following the requirements of the NEC and adhering to industry best practices, you can ensure that your electrical system is safe, reliable, and code compliant.